Hello everyone, thank you for coming. I present you Leszek Szczepański, Senior Gameplay Programmer from Guerrilla Games, Netherlands. Leszek, welcome.
My people, sons and daughters of Helgen. For many years, we have been a broken nation, shunned, oppressed, and conquered by those that we had tried to escape. That's how 13 years ago, the story of Guerrilla Games started. That's the intro speech of Scholar Visari from the first Killzone, back from 2004. Hi. I hope you're all awake in this beautiful morning in beautiful St. Petersburg. My name is Leszek Szczepański, and I'm a senior gameplay programmer at Guerrilla Games in equally beautiful Amsterdam. Today, I come to you to talk about the technical journey that Guerrilla Games had to go through in order to create Horizon Zero Dawn. Now, for those of you who do not know, Horizon Zero Dawn is an open-world action role-playing game exclusive for the PlayStation 4, and it is set in a lush, post-apocalyptic world where gigantic machines have taken over and humanity is no longer the dominant species. So, Guerrilla Games is a Sony first-party developer from Amsterdam. And until recently, we have been known for the series of PlayStation-exclusive first-person shooters, a series known as Killzone. There has been 6 titles on 5 different platforms. And that means that for over a decade, we have been making first-person shooters. Somewhere around 2011, we felt change is needed. We felt that we want to stand before the world and present something completely different. After months of pitching, proposals, and discussions, the project that would eventually be known as Horizon got approved. And from the very start, it was supposed to be a big, ambitious, open-world RPG. Now, the problem with that was that we needed to change a lot. We stood before this dramatical update of our tools, technology, processes, methods, and thinking. It is as if Scholar Visari would stand before us in flesh and said, they cannot imagine what awaits them. Now, we have been making shooters for over a decade and decided to build Horizon in the end. What you can see here is pretty much the list of games that used our engine. And the history of our engine is the history of Guerrilla itself. And although it did go through significant changes over the years, especially during console generation transitions, the code that we use in Horizon Zero Dawn is still has its roots in the original Shell Shock and the original Killzone released 13 years ago. So as you can see, around 2013, when PlayStation 4 hit, we decided to share our technology with other developers, with Supermassive Games and with Kojima Productions. And that's where our internal tech became the Decima engine. Now, a game engine, especially nowadays, is a gigantic beast. And there are many, many ways, many angles from which you can look at it and the way you can talk about it. And that's pretty much what Guerrilla Games has done. So I listed some of the talks which discuss our engine and our process from different angles. So things about rendering, threading, tools, these kind of things. Also, our managing director later this year at the DICE Summit will talk about the journey that Guerrilla itself had to go through in order to create Horizon. In this talk, I will discuss the systems that we need to change or create for the purpose of building a big open-world role-playing game. All while starting with technology purpose-built for creating first-person shooters. I will also evangelize component-based architecture a little bit. So first, let's have a quick look at what, on a more technical level, differentiates role-playing games from first-person shooters. So the fundamentals are pretty much the same. So you both need rendering, sound, threading, these kind of things. However, role-playing games tend to have this bigger amount of content. And that means that you need to upgrade your tools. That means that the tools need to be more efficient so that you create more content quicker, be more debuggable, so you be able to catch errors much earlier. But also, because the player touches so much more content, saving has to be done also more smartly. If I remember correctly, my Fallout 3 save was about 300 megabytes, and that is like pushing what is allowed on a PlayStation console. So we need to think a little bit differently about what we will be saving. A first-person shooter also typically can be divided into separated levels. And that means that the decisions that the player makes in level A usually do not transfer to level B. But that also means that if an error occurs in level A, it doesn't have consequences in level B. In role-playing games, because you want decisions to have consequence all over the game, that means that also a minor bug that occurs at the beginning of the game can have far-reaching consequences by the end. And finally, RPGs are expected to feature more types of activities and resources. So we're talking about things like combat, crafting, conversations, mini-games, character building, puzzles, and actually more. And that means that we, as developers, need to create more systems to enable these kind of activities. Now I will talk very briefly about some basic concepts that we use in our engine. None of it is revolutionary, but just so that all of us are on the same page when it comes to terminology. So first of all, conversion. The game data that we use in our engine is stored in a text format while being edited. Now, before the game is launched, we go through a process we call conversion, which turns it into a binary format which is optimized for the device that we will be playing the game on, well, in this case, a PlayStation. Also, we use this conversion for purposes like compiling scripts, but also during that time we check for errors in contents, so missing links between game objects or other invalid issues. And the game itself only interacts with this binary data, and that binary data is also what ends up on the game disk. Second, resources. So game data is stored in objects that we call resources. Essentially, it's a C++ object which holds some sort of game-relevant information. Each resource has its unique universal identifier, and of course, they are read-only. Objects in game which state is modified at runtime are called, in our case, instances. And an instance object only holds a pointer to appropriate resource object, which will define it. And of course, it is possible for a single resource object to spawn multiple different instances. Third, entities. Everything in the game world, which is not just simple geometry or a location marker, is an entity. So the player is an entity, a robot is an entity, a destructible tree is an entity, the camera is an entity. And the way we define them is that we use a component-based architecture. So the entity itself is a very small object, and the components which we attach to it define how it looks, how it functions, and what it actually is. And finally, messages. So we use this very sort of textbook object-oriented mechanism by sending messages between objects. And the way we approach it is that a message is just a small C++ class derived from a message class, message type, and it is being sent from object to object. An object needs to declare that it handles a specific type of message in its runtime type information. And for objects which are composed of multiple other big objects, like entities, the way it works is that an entity receives a message, it doesn't do a lot of it, but passes it to components, and the components react to the message. So they modify the behavior of the entity or provide information to whatever sent the message in the first place. Okay, let's go with the meat of the whole presentation. Let's talk about the first system. Let's talk about something simple. Character and skill progression. In every role-playing game, you want the player to gain experience, to add just their levels, to gain new skills, new abilities. Typically in first-person shooters, that's not the case. Typically, you just give the player a gun or a better gun, and that's it. So we needed a new system just for this purpose. So what we did, we called these abilities perks, and over time, a player unlocks perks while playing the game. Now we have two types of perks. A passive perk is essentially a flag. A system can ask, has the player unlocked this perk? And if yes, it can adjust its behavior. If not, it can do something else. More interesting are the active perks. So the way it works is that we have a perk resource, and that perk resource links to a component resource. When the player unlocks that active perk, the components that this perk links to are added to the player entity. So the moment the perk is unlocked, the behavior of a player entity is modified by the components the perk links to. Simple, I hope. Something a little bit more interesting and dear to my heart. Quests. So role-playing games are quest-based games. You have missions to accomplish that might take hours. We wanted to have complex, interesting, non-linear quests, and we wanted a lot of them. So we needed to have a system which would allow for creation of such quests. However, Killzone didn't have anything like that. It already did have a very simple objective and mission system. And the way it worked is that you needed to have a script running, a level script, which would manually show objectives to player. And by objectives, I mean just textual information on the screen. And it would have to manually also check for the conditions that the objective needs to accomplish. So it would manually have to, in every update, check, has the player reached this area? Has the player killed these enemies? And then change manually the text on the screen. And that is quite simple, but it's also very limited, kind of difficult to debug, and definitely not scalable. We need something dramatically different. So the way we approached it is that we created a system which defines a quest as a probability space defined by a graph. Each node of that graph is understood as part of the quest story, a quest step. Each step is connected to an action that the player needs to perform in order to progress. And the way we define these actions is that the quest system listens to messages from all over the game. So if an action that the player needs to perform is kill a robot, it will listen for all kill messages that our destructibility system sends and react accordingly. So essentially, our quest system is a listener to all other game systems and sits at the top of a whole game. Now, if you're a little bit more interested in this particular topic, I made a talk about it earlier this year in Moscow. There's a link to the talk if you, I think these slides will be available, so if you're interested, you can just go follow the link. Now, I'll show you an example of how this actually works. So this is an example of a relatively simple quest. It starts by the player approaching a distressed villager, and that villager asks the player to kill all the insects that have infested the field in which they work. So we have a start. That's the start of our quest. And that means that that start is listening to the conversation system to send a message that the player has reached a specific node in the conversation. Once that happens, the start section, the start step of a quest is completed. Then two options open before the player, step A and step C. In step A, the player needs to eliminate all the insects. Essentially, we're listening for kill messages, as I mentioned earlier. In step C, the player needs to talk to the swarm queen. In this case, we'll be listening again to the conversation system to notify us that we have reached a node in the conversation with a swarm queen. Now, what is important here is that these two steps are not mutually exclusive. These are options that open before the player once the start step is completed. So the player is free to complete step A, step C, or both. Now, once the player does complete step A, once the player does eliminate all the insects, the option to slay the swarm queen opens before them. And in this case, again, we're listening to kill messages. If the entity, the swarm queen, is killed, the quest will react and complete B. And here it will be a little bit different. If you can see, there is a red line going from step B to step C. And that means that completing step B will invalidate step C. That means that once the player completes step B, it's impossible to go to talk to the swarm queen. However, there is no line in the other direction. And that means that it's absolutely possible for the player first to talk to the swarm queen, and complete step C, and then complete step B. Well, regardless of what the player does, the option to end the quest opens before them. And in that end quest, we will be either listening to a conversation message again, we will talk to the villager, or we will be listening to the physics system that we have entered the collision volume of the village, and by then we end the quest. So regardless of the state of all other steps, once the end step is reached, the quest will finish. Now, this is a screenshot from our quest editor. And as you can see, that graph which I just showed you is exactly the way we work, with some additional information inside these nodes of the graphs. These boxes inside the nodes define the specific messages we're waiting for, and some textual information we'll be showing to the player. Okay, next thing, items and inventory. So in a role-playing game, it is expected that the player will grab loot, improve their character, get new stuff, new equipment, new weapons, the whole grind of going through dungeons. So we needed to have a fully fledged inventory system with containers, item persistence, various item types, and it should also allow for trading of items between characters as well as crafting. Now, we already had an inventory system in Killzone, but it was actually quite simple. Everything was either a weapon or a resource. So things like ammo, armor, or health. We didn't have containers. We didn't have any complex item types, and the dropping logic was very limited. What we did have was very robust damage logic. So everything related to weapons, obviously, we had, and that meant we couldn't rewrite the whole inventory item system from scratch. It needed to be adapted, and that resulted in a set of interesting problems. Most important of which is the problem of item persistence. What is item persistence? In a video game, when you have an item on the ground and you pick it up and then you go and put it in a container and an NPC goes, takes it out of the container and walks away and drops it again on the ground, if the item persistence is done well, the game can track that this has been the same item from the very start to the very finish. However, in many first-person shooters, that is not important. So in Killzone, what we did is that an item would be represented by two different entities. A separate entity for the pickup on the ground, and a separate entity for the item that you're carrying in your arms. And the only thing communicated between them was the amount of ammo. Nice, simple, elegant, and efficient. What we did is we exploited our component system again. Because an item was an entity, we just created an item component. And that item component itself had two lists of components. One list, which would have components which are specific to being on a pickup, meaning on the ground. So things like physical properties or a simpler model. Or stuff which is relevant, or a list of components that are relevant when it's equipped. So all the damage logic and some more complicated animated model. So when the item got dropped, set of components got removed, another set got added. When the item got picked up, another set got removed, another set got added, and it seemed to work fine. Now, we needed also to deal with the problem of containers and merchants. Of course, this is our role-playing game. Thankfully, that wasn't a big issue. Inventory is also a component. And after some cleanup and some minor work, we managed to be able to attach that inventory component to pretty much any entity. So a robot, a chest, an NPC could contain items. That wasn't a problem. Then we derived another component from that inventory one, which would be specific to merchants. And that merchant component contained information about prices, about which items the merchant is interested in and which not, and of course some logic regardless to updating the stock of a merchant. Conversations, the bread and butter of every RPG. Why kill the dragon if you can seduce it? We needed to create a system that would allow for the player to engage in interactive conversations with NPCs. And in Killzone, we did have this option to allow the player or other entities to walk, talk, and act in a scripted way, but there was no way to do it interactively. In Killzone, it was possible to have all entities, including the camera, to act in a scripted way, where all actions were defined in a precise timeline, something that we called sequences. For Horizon, we built sort of a superstructure over it, something that we call sequence networks. And the way this works is that you have a sequence running in which Aloy is talking to an NPC. And after that sequence ends, the graph will choose another sequence to play, probably another part of a conversation, and so on and so forth. But because this is a graph, we have also some sort of flow controllers. So we had 3 of them. First of all, we have just branches with different choice logic. So you could choose a random sequence from a list, or you could go one, second, third, and so on and so forth. Or you could add scripted conditions to them. To see, to control more finely how this is supposed to work. And also we had player choice, which meant that once the player choice node got hit, the sequence would go into this loop state in which Aloy is standing in an awkward way and waiting for the player to make a choice. And once the player chooses in the UI what's the next sequence supposed to be, that one will play. And finally, we had breakout logic, and that means we gave an option to break any sequence at any point, not wait for it to end, to go to another one. And that was usually used when an NPC was just standing, hanging around, and you wanted the player to approach them and then go into conversation. So that hanging around, standing would be one sequence. We would break out into a proper conversation. Now, first of all, this system proved much more robust than we initially thought, because you could control entities in any way and have superstructure logic on it. We didn't use it only for conversations. We actually used it quite a lot. So for example, if you go to Meridian, the biggest city in Horizon, and you have an NPC which is cleaning the street and then going to have a beer and then going somewhere else to chat with their friends, all of these are separate sequences, and the order in which the NPC performs them is part of a network managed by that logic. Also, we managed to create tools which allowed us to generate sequences and these networks from written text. So if a writer wrote a dialogue, we could just, with a press of a button, create initial rough voiceovers, camera positions, gestures, and so on and so forth. And that was used to create first pass of pretty much every conversation we had. Now, this is a screenshot from our sequence editor. And this is essentially how we create these sequences. So every block that you see here is either an actor, an entity, or a task that it must perform, talk, walk, or animate. And this is how most of the cutscenes in Killzones and Horizon were made. What we built on top of that is our sequence networks editor. So this is a graph which represents some sort of a conversation. Each white node is a sequence that will play, essentially this talking element. And all other nodes are flow controllers, like branches or conditions. Scripting. So nowadays, the sad or happy reality is that we need scripting languages in our engines. We want to give the designers the power to create complex things, but we don't to burden them with things like C++, God forbid. So we need to have a scripting solution that would fit for a massive open world role-playing game. Scripts need to run efficiently, be debuggable, and not be complicated to use. Now, in Killzone, we already had a scripting solution. As probably many of you, we were using Lua. Now, Lua is fine, but first of all, it's an interpreted language, that means it's slow. The second thing, it's easy to create errors because most of the references to game objects are done through string. So if somebody makes a typo, you won't catch it until the script runs. And essentially, any other error usually is caught only when the script runs, which is way too late. We tried to help ourselves during Killzone era by creating tools around that. So this is I think, Killzone 3 era, Killzone Shadowfall state machine editor. So what you see here is a visual editor in which every box is a state. every box within a box is either a command or a condition, and the lines between the boxes manage state changes. And every box there is defined by some sort of a Lua function. We managed to connect this to our tools, so it was easier to find proper references to objects. And this was better, but it was still insufficient. Actually, even in Killzone Shadowfall, where we started to experiment with more open structures, this proved to be a problem. We needed something completely different. We decided to use a custom visual scripting language. We wanted for the designers to use a graph, sort of like Unreal Engine does or other engines do. In that scripting language, in that graph, each node would be implemented as a single C++ function. It was also possible for the designers to combine a bunch of these nodes to create compound nodes, sort of they could create procedures or functions. And during conversion process, all these scripts will be transformed into C++ code and then compiled by Clang into dynamic libraries. And these dynamic libraries will be loaded into game at runtime. That was much better. First of all, we had a compiled language, so much faster. Second of all, we integrated everything into our tools. So we didn't reference objects by string anymore. The tools knew that you were referencing an object. If you remove that object, at editing time, you would know that there is a problem. Now, this is pretty much how it looks. So you have C++ function of a C++ code of a function, which I think finds a quest item and an entity, and what you see below is a one-to-one representation of that code as a node in the script code. This is an example script in our script editor. Essentially, again, every node is a C++ function. You have flow controllers. You have some Boolean logic. You have passing of data. This is, I hope, pretty common, but again, worked efficiently. Also, because video games like to use state machines, we also build, on top of our scripting solution, a state machine logic. So this is our state machine editor. And each block here represents a state. Script, just like the one you saw before, manage script and state transitions, and also what does the state machine do in each state. And finally, state machines very often are message handlers. So they are attached to entities or to scenes, which I will mention a little bit later. And they receive messages and act upon these messages. So scripts could also be run when received generic messages. Streaming and world management. So the problem we were trying to solve here was really, really simple. We wanted to have a big open world and not run out of memory. In Killzone, we already had a way to asynchronously load data, but it was very simple. The way it worked is that you would divide the levels into these chunks, and they would be chained in a linear fashion, divided by elevators or by corridors. When the player would enter a corridor, the door would close behind them, and the old piece of a level would get loaded off, like removed from memory, and while the player traverses the corridor, the new part of a level would get loaded. From perspective of the player, they just traveled a corridor, but we managed to add and remove some content. Now, this was working quite well for a corridor shooter, but it wouldn't cut it for an open world game. Again, we needed something completely different. So the way we approach it is that we divided the world into tiles and into scenes. Tiles are a very simple concept. Essentially, we have a grid, and each tile of that grid contains only geometry. So all the mountains, all the non-destructible stuff is on a tile. And they are streamed depending on the player's distance. So I think we had constantly 4 tiles streamed in. Now, the scenes are a little bit more interesting. A scene essentially is a collection of objects that can spawn in the world. So mostly entities, but also additional geometry. It would contain a state machine which would define its behavior. So the state machine I showed you earlier could be connected to a scene. That scene would get messages from the scene manager about player being spawned, player entering, player leaving, entities being killed, and so on and so forth. A lot of different things. And they could react accordingly. Size of that scene would be defined by the user, and that means that the designer would have to decide how soon we load that piece of content. Some scenes are very big, some scenes are very small, some scenes contain all of the data, some a little bit. The designer would have to figure out when we start streaming in the information, when we start loading. Also, it was possible to load the data manually, but that wasn't used very often. Now, what you see here is a screenshot from our 3D editor. And it shows a zoomed out, very zoomed out, screenshot of a scene while being edited. So the green ring that you see is the outer skirts of the scene. And the icons that you see inside, as well as some of the geometry, are objects that are inside that scene. So this is essentially a form of organization. The thing on the left that you see is an outliner, so you could also have a tree view what the scene contains. So there was another problem that we needed to solve. So in a modern role-playing game, you tried to guide the players so that they don't get lost all the time. That means that if you want the player to get the axe of power or any other item, you want to put a location marker on it so that the player can go and find it without issues. Now, how do you put a location marker on something which doesn't exist? I mean, if the player is one corner of the world and the item is on the other corner of the world, that thing is not streamed in yet. So we need to find a way to identify positions of items for content which is not in memory. So the way we approach it is that we introduced a concept we call baking. And that means that every scene contained a list, a lookup list of items that are referenced by quest. Essentially, it was a pair of UID and a location in the world. Baking meant that each time the scene was saved, all these objects which are referenced by quest would get added to the list, or the list would get updated. And each time a quest which does reference the object in that scene got saved, also that list would get updated. So the baking essentially was done by saving, on saving in the editor. Also, we could trigger it manually if an error occurred. And that meant that we constantly had this information about where specific items are. These lists would be loaded at all times, so they're permanently in memory. So that means that a quest, when it needs to reference a location of an object, and that object is not streamed in, it just goes to the appropriate scene, looks at the lookup table, says, I need location of the object with this UID, has a location, puts the marker, done. When the object gets streamed in, it just switches the marker position to the location of the object. When it gets streamed out again, it uses the lookup table again. Game saves and data management. So this is a problem I mentioned also relatively at the beginning about size of save files in open world games. Essentially, we could run out of storage data if we wanted to save everything, and we couldn't allow that, especially on a console where we have very strict hardware limitations of how big the disks are. On a PC, you don't have to care all that much, but hey. In Killzone, what we did is that we saved pretty much everything. So every entity would get its state saved, all of its state. The whole level would get written to disk. And because we didn't have all that information to save in a single level, we managed to keep everything in kilobyte size. Now, in Horizons, this wouldn't cut it. First of all, we would deal with streaming and things which we need to save. And second of all, just sheer amount of data would just go into gigabytes. So again, we need to approach it totally differently. So the way we did it is, first of all, we decided to save only 4 things. First of all, we would save information about the player. So player inventory, the player's character progression, so the level, experience, perks, so on and so forth. And the player's progression through the quests. And the fact database. In Horizon, we introduced the concept of a fact. Fact is a designer user-defined global or local strongly typed variable. So it could be referenced by scripts, it could be referenced by other systems, it could be written to, it can be read from. The reason we did it is that we decided that we won't save any entity information. We won't save any script information. We will only save these 4 things. And it's up to the designers to write the scripts in such a way that when the game loads, they can read from the fact database information and restore every scene in an appropriate way. Of course, we didn't need everything to be restored perfectly, but it had to be restored in a relatively sane way. So if there were 12 dudes spawned in front of you, you killed some of them, you died, you reloaded the game, and there are slightly different dudes, that's fine. But the state of the game would be restored properly. Now, the concept of facts had a very interesting consequence. So in role-playing games, it is quite common to have a concept of a condition. And in this case, a condition is just a script which is attached to a different system. And it manages whether that system should run or not. So things like spawning entities, opening doors, unlocking areas, or quests. Usually the way it's done is that that script is just running in a loop constantly until it returns true or false. And that can get really out of hand if the script, if there's a lot of scripts. Even if they're small and simple, once you have tens of thousands of them, and this, believe me, this can escalate quickly, it can actually have a quite performance hit. Now, what we did, we introduced our concept of condition. And a condition is a specific script which can only read facts, fact values, and return a Boolean, nothing else. So that means that once you create such a condition and you register it, the fact database knows about it. And the fact database, what it will do is it will have this hash map of which scripts, which conditions listen to which facts. When the facts get modified, it will ask the condition to reevaluate. And when it does reevaluate, the system which has the condition will reevaluate it again. That means each condition, instead of being called in a loop, essentially is an event handler for fact value changes. And that was so much efficient, so much more efficient than the initial running in the loop logic. Okay, to sum this up. While building Horizon, instead of fundamentally rebuilding our engine, we decided to make a lot of smaller upgrades and incremental additions. And although we did make an effort to use as many of old systems as possible, elements that no longer fit our purposes, our new design paradigms, were mercilessly removed. Also, component-based design proved that it was quite useful for this kind of big iterations, because you could isolate a lot of information, a lot of functionality in a single component. You could just create new functionality in a different one, and you didn't have to touch or break the old content. So we could slowly phase out old logic while building new. And finally, working on low and high-level systems, as well as tools, proved kind of challenging, because it was essentially building the plane while flying the plane. In the end, it proved quite possible. In the end, we did ship Horizon. This is pretty much it. I hope you found it interesting, and thank you very much for listening.
So this was a great speech. Do we have any questions? Yes, I can see a question there.
I have a simple question. What's your favorite game which you worked on, and what's your favorite game which you didn't work on?
That's simple. My favorite game.
Моя любимая игра — это Horizon, а любимая игра, на которой я не работал, такой нет игры.
Yes, we have a question here.
Yeah, I just didn't understand one thing about tiles and scenes. What's the relationship? Like, can a scene have several tiles or vice versa?
Okay, so the way this works is like sort of in layers. So like the bottom layer are tiles, and the scenes are like on top of them, but they can overlap. So a scene is a tile is always like a grid, but the scenes can be wherever. So they don't have like a direct relationship. A tile never references a scene, and a scene never references a tile. But it's like two separate ways of organizing data, one over another.
More questions? Yes, I can see a question there.
Добрый день, спасибо большое.
Good afternoon. Thank you ever so much for your lecture. Now, did you try to model a live system? Like, a player doesn't influence it, and then you have robots fighting each other. You got robots killing each other. Do you have information like this, or are they all frozen until a player comes to those entities?
Question was whether the game world actually does anything when the player is not there. And the answer is yes and no. We have some very subtle things that happen in the background. So for example, all merchants do have their stock updated over time, but we never implemented anything more ambitious. There were some ideas to have like herds running around and actually in real time being modeled where they move. But to be frank, we just couldn't make it in this time.
Yes, please.
Hi, thank you for your speech. I want to ask, I didn't understand the thing about resources. You said that one resource could be represented by different entities and different instances, right? And so what kind of information you storage in the resources if you could remove and add any component in the runtime? So how it works?
So the way this works is that resource is just a generic name for game data. So for example, you have an entity resource or a component resource or a perk resource. And for components, the way this works is that you have a one-to-one relationship. You have a component resource and you have an instance resource, a component instance. And from one component resource, you can create multiple component instances. And they're like copies until their internal data gets modified.
So, but they have different ID, right?
So the resources have, well, there's one resource. So indeed, all these objects have different unique universal identifiers.
But what would happen if you have an object with one ID, then remove all the components from it and add different components? The ID will change.
Well, the thing is that
the same object with...
Well, the UID of the entity remains the same. So you reference the entity, and only the behavior of the component of the entity changes based on the component.
But you can change the object completely. So, remove a geometry and another, and still the same object.
We can. So essentially, an entity itself doesn't contain information. So if you wanted to push it to extreme, you could. You could essentially change a robot into a,
okay, I get it. Thank you.
Player.
Any other questions?
Здравствуйте, я хотел спросить...
On creating routes. The question is about creating routes. If we load
good now.
when we stream in, how do we construct routes? If we have in a compass, if we have one direction, it's not necessarily probably possible to go there. So to create a route from one object that is streamed in, you need to pass through the world and you need to stream in several objects.
So essentially we have this whole, that was actually a problem which we were hitting a lot. So there were situations in which many objects would reference each other, and you at some point wanted to stream a weapon, but it would reference a robot, that robot would reference a different robot, that robot would reference another object, and you run out of memory. So yeah, this was a problem that we were facing, but we also had a tool which allowed us to show hierarchies of all links between all resources. So it was possible to figure out, hey, this is the link which makes, provides this additional information which we don't need. We need, unfortunately, manually manage these kind of structures so that we never load too much at the same time. And the scenes were used for managing loading of all the objects. So yeah, this is a problem we did hit, but we essentially just looked at the data graph and tried to optimize it.
And we already have the next question.
At first for sharing your experience, and actually I have two small questions. First of all, just to clarify things, it's about single player RPG, so there is nothing about networking and so on, right? And the second one, what about rendering, some upgrading of rendering when you coming from horizon, how it called next one game and previous, from previous game to next one with open world.
So when it comes to rendering, I'm not doing graphics at Guerrilla, so I cannot talk a lot about it. But most of the changes to the rendering pipeline which we did was for Killzone Shadowfall. So in the list which I showed before, there's a list of talks which also talk about rendering in Horizon. So I think earlier this year a friend of mine did a talk about cloud rendering for Horizon at SIGGRAPH. So I think these slides will be available, so you'll be able to access more rendering relevant talks if you so desire.
Okay, great. And I already have the next question.
Thank you. I have seen some presentation about Killzone, and I wondered, it was 5 or 6 years ago, and I wondered that you used Maya as a vault editor or editor of game objects. Does your company still use this approach, and what is advantages and disadvantages?
So we don't. And the reason for that is that Maya is not a game editor. If you ever think of using Maya as a game editor, don't. It was like legacy because it was good enough for Killzones, but it got more and more difficult over time. And for Horizon, that would be impossible to ship the game in a reasonable time if we used Maya as a game or entity or anything editor. So we still use Maya for geometry. We still use Maya for models. But we created a whole new set of tools for managing data, for managing levels. The 3 editor I showed you, this is how we build our levels, our areas. So we have new tools which are purpose-built for making games. Maya was a stopgap measure, and we stopped doing that, and for the best.
The next question.
Thank you for your speech. The question is, do you have the separate team to create tools, or is it the exact same people that are making the whole game engine, and how the process of making tools and making game engine interacted? Thank you.
So the way we do it is that we do have a small separate team which focuses only on tools. But when we were researching how do we want to approach tools in our engine, when we were just starting to build them, we made the decision to write everything using C++. And that was for the reason that other people in the company could help with building the tools. So yes, we have a specific team. But if there is a system that somebody from another team was working on, they are free to create their own editor using our toolset, or modify or help with the tools. So essentially there's, again, a set team, but other people try to help.
And first, let's ask the question from this part of the room. Okay?
Talk and presentation. I have a question about quest system. I realized that quest system, game world affect quest systems by sending messages, but how quest system affects the game world? For example, if something entity should be spawned only if you have a particular quest or something like this. Thank you.
So this is actually quite a complicated topic. At some point during development, we made this philosophical choice about how our quests should interact with the world. And the idea was that we don't want the quest to drive the game. We want the quest only to follow the game. So usually what happens is that the game doesn't care that the quest has updated. Other things have happened, meaning if you need to kill a dude, the game will spawn new entities because you killed the dude, not because you progress the quest. In some cases, we have situations in which the game reacts to quests, but this is for extreme situations, like major plot points or other cases. But in general, the game tries to not to react to quest changes.
And we have time left only for 2 super quick questions, one from there and one from that part of the room.
Thank you for your presentation. The question is, do you have plans for to bring Horizon to next level? I mean, MMO, like GTA Online or something?
I honestly cannot talk about it.
Okay. Give me something.
Sorry?
Give us something. No.
No, unfortunately, I can only talk about technical stuff.
Okay.
And our last question.
Hello. And how well is multi-threaded your quests, your script system? I mean, did you manage to split it in several threads, and how much time does it take in frame?
Okay, so actually we didn't try to solve this issue because usually a script is connected to a different system. So you have an entity which runs its state machine, and these are scripts. You have the quest system which has some connections to scripts. You have scenes and so on and so forth. And these systems run multi-threaded. So what happens is that we have the whole entity update logic, and all entities are updated in an asynchronous way. And they run their own scripts also in this asynchronous way. The only thing is that we needed to do some smart things in regards how we access objects externally. So what happens when you want to access an object from a script which might be in a different thread, and that we did on a case-by-case basis. Thankfully, we have a system that whenever you do that, you have like a big error. So we managed to cut these errors relatively quickly.
Thank you. That was absolutely great.
Thank you very much.
We have many great people here at 4C today, and here's one of them. Hi, please introduce yourself.
Hello, I'm Alexander Markovic. I am Creative Director at Ministry of Games, and I'm here to talk about city building games and design principles of those.
Nice. Do you remember your very first video game that you've played?
Sure, it was The Prince of Persia back in something like 89 or whatever it would have been. Yes.
It's a great game back in the day and still. What's your favorite game of all time today?
I guess I like mobile games, so at the moment I think my favorite game would be probably something like Brawl Stars or Clash Royale, so Supercell PvP titles, or on the other hand some city building titles like Township.
What do you think about the state of modern video game industry overall?
Well, I guess there is a lot happening at the moment, which is awesome. The core games are doing awesome stuff, the casual games are doing awesome stuff, so I think it is awesome that inclusion is happening on all sides, right?
Anything that maybe irritates or saddens you, something that you don't like in the state of game dev today?
Well, the only thing that might sadden us is the sometimes there is a bit of lack of inclusion happening, and sometimes there is a certain amount of kind of toxic behavior that occurs in the gaming circles. But other than that, I think it is just moving in the awesome direction.
Well, it is moving in an awesome direction, and we're here to try and foresee it. Speaking of which, what do you see happening in the industry in like a 10 years' time? What will be the new thing, the new trend, do you think?
Well, hopefully the mobile games stay relevant, right? But other than that, obviously AR and geolocation games are super interesting, and stuff that's happening with that is super exciting, and also hopefully as things move forward, we get more inclusive or like more engaged worlds that we kind of play together with each other. And I think this is something that we're hopefully moving towards too.
Well, you're part of the industry, you can help move it forward. Speaking of which, how did you end up in the industry? How did you come here?
Well, I guess as anyone else, I just kind of liked the whole idea of the escapism of the games that was offered to us as we were young, and I just kind of stick with them throughout my youth, and it was a logical choice growing older, right?
What's more important for you in games that you like graphics, storytelling, the gameplay, or maybe a combination?
I guess in the end, for me, it comes back to the community and kind of the shared experience of playing the games. So it is in the end about kind of multiplayer of it.
What about the single-player games then?
Which are also awesome. There is nothing about games that is not awesome, right? So single-player games also cool. Whatever story-driven RPGs, story-driven text-adventure games. There is nothing to dislike in those either, but for me, just kind of the multiplayer experience is something that drives the medium forward into kind of this new, less explored areas of just kind of playing with your, children or with your parents or with your grandparents. Why not? And I guess this is something that just excites me.
So the future is in multiplayer and socializing in games. Is that right for you?
Well, I hope it is I guess what I'm saying.
Well, we can move it over there. St. Pete, we're here today. What do you think about the city?
A beautiful city, repeat. Awesome times to be had all around, and I'm glad to be here. Thankful for the opportunity.
Glad to have you here. Also surprised you know the cult song about St. Pete. What about the conference? I know it's the first day, but what are your impressions so far? Maybe expectations?
Well, I've met some awesome people all around. I'm looking forward to hearing their talks, to hearing their thoughts on the future of gaming and the future of the industry, and have high hopes.
Any specific speech you're maybe looking forward to? Somebody you want to listen to?
So there is, for example, the Greg Street, the design director of League of Legends, will be talking about using user feedback to improve your game design. So this is something that, for example, I'm very interested in. And also anything from game design track is something that appeals to me very much.
Well, hope you find it useful. And finally, if you were standing here in my place interviewing yourself, what question would you ask yourself?
Whoa, not sure at all.
I guess you have all the answers then.
Yeah, possibly.
Well, I hope you find more answers here on 4C, and thank you very much, and have a nice time.
Thank you.
So we've prepared a few questions for one of our speakers. Please introduce yourself.
Hello, I'm Ville Rauma from Fingersoft, Finland. So, yeah, nice to meet you.
Nice to meet you too. Please tell me, what's the first game you have ever played, the video game?
I think that would probably be maybe Microsoft Flight Simulator 3. And
It was your very first, right?
Yeah.
All right. Which one is your favorite today?
Right now, basically, Divinity Original Sin 2 is like really awesome.
It's amazing. I gotta agree with you there. And what led you to the gaming industry? How did you start?
Well, basically, I was studying in University of Oulu, and we had a training period where you go to a company, and there happened to be a game company in the list where you can pick where you want to go, and I was like, yeah, I want to go there. So that's how I got started.
So they just took you in?
Yeah, because it's like the companies kind of volunteer that we'll take trainees from the university, so you can kind of pick where you want to go. So yeah.
Sounds great. So what is your favorite thing about the video game industry today?
Well, I don't know. It's like it's really hectic, and it's quite kind of free kind of environment where people can really be, you know, who they are, and it's kind of laid back. So I think that's pretty cool.
It generally is, but are there maybe things that make you mad or sad in the today's state of gaming industry?
Well, I don't know, like, it's difficult to say. Sometimes there are things, but nothing pops to mind right now. Like, maybe sometimes, like, they, especially like huge studios kind of focus on single thing. You know how it is, like sometimes there's only World War II games, and next you have only like future mech games or whatever. So it's like always these big trends and less about like innovation and new type of games. So maybe that.
Speaking of trends, do you see any trend surfacing in 10 years or so? How do you view the gaming industry in the nearest future?
Well, long term, like 10 years, I think probably there's gonna be big changes. Like of course VR, AR are big, but right now they're like really new stuff, so it's not really like a big business opportunity right now, but that's probably gonna be big in the future. I think it's gonna take a few years, but yeah, at least that.
So you feel like technologies are gonna be the game changer here?
Well, at least with VR and AR, I feel like the experience is so awesome that when you do that, everybody who tries it thinks it's awesome, but right now it's just too cumbersome and complicated to do, so I think that's the biggest issue there. But yeah, also of course there's gonna be probably like different trends in the way games, like the kind of like the free-to-play model right now, how it is, probably will change. It's always changing, so yeah.
That's true, but speaking experiences, what do you think is more important in a game? Like the age-old question, it's the graphics, it's the gameplay, the storytelling?
Gameplay, of course. Yeah.
The simplest question of all. Okay, so what do you think about St. Petersburg?
I love it so far. It's first time actually for me in Russia and in St. Petersburg. So yeah.
And what about the conference?
Yeah, it's looking really awesome. It's like well organized, so I like it.
What was the best question you were asked so far?
I don't know which game you are playing right now, of course, because I'm waiting to go back home so I can continue playing.
I completely understand you there. Which question would you ask yourself if you were interviewing yourself?
Oh, that's a hard one. You know, what's going to be your next game? And I couldn't answer right now because we are working on a lot of prototypes and we'll see what it's going to be. But yeah.
Great. Are you looking forward to any specific presentation? Which do you want to listen to most?
Yeah, I did mark a few. I don't remember the titles right now, but they were like interesting because there's a lot of like really cool people here who know like a lot about a lot of things. So yeah. I think for me, maybe on the kind of leadership business track is maybe the most kind of interesting for me right now because that's my job. So, yeah.
Well, you're one of the cool people here, so thank you for coming and thank you for being a part of this.